Hello friends, the topic for today is nature of software. Computer software continues to be the single most important technology on the world stage, and it is also a prime example of law of unintended consequences. 60 years ago, no one would have predicted that software would become an indispensable technology for business, science and engineering. We can't run the modern world without software. National infrastructures and utilities are controlled by computer-based systems, and most electrical products include a computer and controlling software. Industrial manufacturing and distribution is completely computerized, as is the financial system. Entertainment, including the music industry, computer games, and film and television, is software intensive. Therefore, software engineering is essential for functioning of national and international societies. In today's video, you will learn the nature of software. Let us start. Welcome to our channel Engineering and Technology for You. If you have not subscribed to our channel, kindly subscribe and press the bell icon so that you will get notifications for future videos on this subject. Nature of software. This is the topic for today. Let us start with the dual role of software. Today, software takes on dual role. It is a product, and at the same time it is the vehicle for delivering a product. Now, as a product, it delivers the computing potential in computer hardware, or more broadly, the network of computers that are accessible by local hardware. So, computing potential we can access by local hardware. So that is the delivered by the product. Then whether it resides within a mobile phone or operates inside a desktop or mainframe computer, software is a information transformer. So it transforms information. So producing, managing, acquiring, modifying, displaying or transmitting information. So that is the main role of the software. So it can be as simple as a single bit or a group of bits, or as complex as a multimedia presentation derived from data acquired from dozens of independent sources. So the complexity of the software varies from simple to complex. Then as a vehicle used to deliver the products, software acts as a basis for the control of computer. So control of computer, so that is the main role played by the operating system. So operating system manages the computer hardware as well as the memory and multitasking and the user interface. So the software acts as a basis for the control of the computer, and then it also say communication of information. It does the role of communication of information. For example, if you take say whenever we use the internet or networks, at that time we'll be using the web browser. So web browser will communicate your information to the outside world. Then software can also be say act as a creation and control of other programs. So here we take the example of software tools or utility softwares and environments such as the integrated development environment IDE. So there we can say, create other programs, and also we can control other programs. For example, the antivirus software, it will be able to remove the virus from the system. So that is how these are called as the software tools. Then let us go to the next. What does software deliver? So software delivers the most important product of our time, that is the information. So it transforms personal data so that the data can be more useful in local context. So that is maybe you can take the individual transactions, financial transactions. So they are transformed, and then you can make it useful for your personal use, or with the help of that you can say use the data later on. Then it manages business information to enhance competitiveness. It provides a gateway to the worldwide information networks, that is the internet, and provides a means of acquiring information in all of its forms. So if you it manages business information to enhance competitiveness. That means if you are having a business, you can make use of the software for the digital marketing and even the advertisements. With the help of that you can make your business competitive, and also it provides gateway to the world of information networks, that is internet. Say if you are taking the browser, you are doing browsing with the help of the browser. So Chrome, Firefox, Internet Explorer, these are the examples of the browsers, and you can acquire information in all its forms. Means you can download the video, then audio files, even the images or text. So in all the forms you can acquire the information with the help of the software like the browser. Then it also provides a vehicle that can threaten personal privacy and gateway that enables those with malicious intent to commit criminal acts. So this is with respect to the hacking and ethical hacking. So with the help of the software you can have a gateway, or that will enable, means they will protect your system from others. Okay. Then changing role of computer software. Now the role of computer software has undergone a significant change over the last 50 years. So this is because dramatic improvements in hardware performance, profound changes in the computing architectures, vast increases in memory and storage capacity, and a wide variety of exotic input and output options have all precipitated and sophisticated the complex computer based system. So here there is a lot of improvement in the hardware performance. The CPU, they have become more, the speed has increased, and there is a lot of increase in the memory. Nowadays you will find the memory in gigabytes and terabytes is available, and the input output options, like we can have mouse, keyboard. Apart from that, we can have the other inputs, like the for gaming we have the joystick, and for laptop also we have other uh, pad. So that has increased the performance of the overall computer system. So sophistication and complexity can produce dazzling results when the system succeeds, but they can also pose huge problems for those who must build and protect complex systems. So this has added to the complexity in the developing the system. And today, a huge software industry has become dominant factor in the economies of industrialized world. Teams of software specialists, each focusing on one part of the technology, required to deliver a complex application, have replaced the lone programmer of an earlier era. So this is very important from your point also, because now you, after passing out as a B graduate, will join the software industry, and there you'll have to work in team. So the team of software specialists, so each focusing on one part of the technology, required to deliver a complex application. That's why the complexity of the application is so vast that for each part you will need a team of specialists, and they will be working on only that part. So that is what is the uh, software has become now today. Then, and yet the questions that are were asked to the lone programmer are same questions that are asked when modern computer based systems are built. So earlier the programmer used to write the program, there was no team. But nowadays, with say large team also, the same questions are being asked. What are those questions? Let us see. The first is, why does why does it take so long to get software finished? See, generally the time for making the software is 1 year, maybe more than that, 1 year, 2 years, or it can be minimum 6 months, 3 months at least. So that's why the it is taking a lot of time for making the software. Then why are the development costs so high? See, as number of engineers involved in making the software is high, so generally the development cost of the software will be high. For example, if you take the Windows operating systems, Windows 10 or earlier operating systems of Windows, so thousands of software engineers, they have written the code for making the operating system. So it's not, and they have worked for thousands of hours. Then only it is possible to build the operating system. Then why can't we find the all errors before we give the software to our customers? So that is also a very, it's not possible at all. So the as we make the software, bugs will be there in the software, and then they will be removed after that when it is in use. And why do you spend so much time and efforts maintaining the existing programs? See, the existing programs, they are, we can't replace them. So that's why you have to spend time in effort maintaining the existing program. Why do we continue to have difficulty in measuring progress as software is being developed and maintained? So this is again a very difficult task to measure the progress of the software, because when we study the project management, at that time some of the aspects you will be able to study that. So these are many questions that are a manifestation of the concern about software and the manner in which it is developed, a concern that has led to the adoption of software engineering practice. So because of these questions only, software engineering has come into existence, and that's why it is necessary to study software engineering. Without that, you cannot develop the software. Then defining software. A textbook description, if you look for the software is instructions, that is computer programs that when executed provide desired features, functions and performance. So then secondly, data structures that enable the programs to adequately manipulate information. So maybe you will be studying this subject, data structures. So they are very important in the software. So software, we can say, is a data structure that enables the programs to adequately manipulate information. So with the help of the data structures only, the software is able to manipulate the information. And then thirdly, descriptive information in both hard copy and virtual forms that describe the operation and use of programs. So it is again descriptive information with virtual forms and the hard copy. But these definitions, there is no other question that we can have number of definitions, but it won't be major improve your understanding. That is why you'll have to know the characteristics of the software. What is software? So let us see the software characteristics. Software is a logical rather than a physical element. Therefore, software has one fundamental characteristic, that is, it is considerably different from hardware. So when you are studying hardware and software, you have to understand this. Software is different from hardware. So software doesn't wear out. Now here you will find failure rate as a function of time for hardware. So this is the failure rate and this is the time. So we'll get initially the failure rates are high and then they will become low and they will be stable. The failure rates will be low during this period, and then again after certain time the hardware will start wearing out. So this relationship is often called a bathtub curve. It indicates that hardware exhibits relatively high failure rate in its say early infant morality, that is as in the early times, and for some period it is very low, this period, and again it rises as the hardware components suffer from say cumulative effects as dust, vibration, temperature extremes and many other environmental maladies. So simply hardware begins to wear out. So here at this point it begins to wear out, whereas software will not wear out. It doesn't wear out. Let us see how what it does. Software is not susceptible to the environment maladies that cause hardware to wear out. So in theory, therefore, the failure rate curve of the software to take the form of a idealized curve. So here you can see here we have shown the idealized curve. So earlier there will be the failure rate will be high, and then when the bugs are removed, then you will get a very low idealized curve. The failure rate will be low. Then undiscovered defects will cause high failure rates in the early life of the program. However, these are corrected and the curve flattens as shown. The idealized curve is gross over simplification of actual failure models for software. However, its simplification is clear. Software doesn't wear out, but it deteriorates. So there is deterioration in the software. It will not wear out, but it will deteriorate in the performance. Then these curves, these are the actual curves. So here again there will be a high failure rate, and whenever we make a change in the software, again we'll get a spike, increased failure rate due to the side effects. Again we have another change, again it will give a spike. This is the actual curve. Let us see the actual curve for software. So during its life cycle, software will undergo a change. Now, as the changes are made, it is likely that errors will be introduced, causing the failure rate curve to spike. As we have seen just now, the spikes in the actual curve. So, before the curve can return to the original state failure rate, another change is requested, causing the curve to spike again. Slowly, the minimum failure rate levels begin to rise, and the software is deteriorating due to the. So, this is what we have seen in the figure. Then another aspect of wear illustrates that the difference between the hardware and software. When hardware component wears out, it is replaced by a spare part. So in case of software, we don't have the spare part. Every software failure indicates an error in the design or in the process through which design was translated into the machine executable. So therefore, software maintenance tasks that accommodate requests for change involve considerably more complexity than the hardware maintenance. So here, to take example, if some part of your vehicle or car is damaged, you can straightway replace it. But in this case of software, it is not possible. So if you want some change in the software, it will add to more complex problem, complexity. Then let us go further. Software application domain. So broadly, we have 7 broad categories of software domains which are continually challenges for the software engineer. The first is the system software. System software is a collection of programs written to service other programs. So they are called as system software. So examples are compilers, editors, file management utilities. So these system softwares they process complex but determinate information structure. So here number of information structures are used and they are complex in nature, but they are being used by the system software. Then other system applications, for example, operating system component, drivers, networking software, then telecommunication processors, process largely indeterminate data. So here the data is determinate, here it is indeterminate. That means it will be again say changing and every time there will be a lot of say unpredictable data. Then application software. So standalone programs that solve a specific business need, and we call it as the application. Application in this area are business or technical data in a way that facilitate business operations or management technical decision making. So here generally these are specific to the particular area of application. So we can have say operation management or logistics, decision making. Those applications can be done with then engineering or scientific software. So generally there are number crunching programs that range from astronomy to volcanology, from automotive stress analysis to orbital dynamics. There is automotive stress analysis. So this is the software which analyzes does the analysis of the stress when the vehicle meets with an accident. Then orbital dynamics. So that is with respect to the satellite and from computer-aided design to molecular biology. So computer-aided design is nothing but making the and say design with the help of computer. Molecular biology, genetic analysis, control. So it will include all the fields, scientific and then embedded software. So it resides within the product or system and is used to implement and control features and functions for the end user and for the system itself. So when the software, hardware as well as the software is embedded within a product, then we call it as the embedded system. Embedded software will reside inside that product. So can perform limited or historic functions. For example, keypad control for a microwave oven or a washing machine, or provide significant functions and control capability. For example, digital functions in automobiles such as fuel control, dashboard displays, braking system. So these are all the examples of embedded software. Then product line software, designed to provide specific capability for use by many different customers. Product line softwares can focus on limited and historic marketplace, example inventory control products or address vast consumer. So inventory control product. So but particularly this is for the product line. So generally this will be used in most of the industries for the inventory. Then we have the next domain is the web mobile app. So this network centric software category spans a wide array of applications and encompasses both browser-based apps and software that resides on the mobile device. So here, all of you are now using many of the mobile apps. Some of the uh, they are both browser-based apps and software that resides on the mobile device. So if you are using same things on the desktop, it will be say browser based. For example, if you take Facebook on your desktop, it will be browser based. Whereas in the case of mobile, it will be based on the apps application. So there is a array of applications we are already familiar with. Then next is AI software, artificial intelligence. It makes use of non-numerical algorithms to solve complex problems that are not amenable to computations or straightforward analysis. So applications will include the robotics, expert systems, pattern recognition. Pattern recognition here again will include the image recognition, voice recognition, or the speech recognition. Then artificial neural networks. So ANN. So that will again include some applications for say medical, so detection of different diseases from the patterns. So that is uh, based on the artificial theorem proving and game playing. So game playing again is a application. Artificial intelligence become a part of software industry, and slowly there will be number of applications which will be based on AI. Simple examples if you take, they are available on the mobile, Siri, and then Google. So those applications based on AI. Then legacy software. So here this part, hundreds of thousands of computer programs fall into one of the seven broad application domains. But some of these are state-of-art software just released to individuals, industry, and government. But other programs are older. In some cases are much older. So these older programs are referred to as legacy software, and their focus of continuous attention and concern since 1960, because they are old and they are being used. So that's why the some of the Danny Ferd and his colleague has described it as they were developed decades ago and have been continually modifying to meet changes in the business requirement and computing platform. So the proliferation of such systems causing headaches for the large organization who find them costly to maintain and risky to. We can't modify them easily, so that's why it is causing problems. Then Leo and his colleagues. So many legacy systems remain supportive to core business functions and are indispensable to the business. Hence, legacy software is characterized by longevity and business criticality. So already they are in the use. That's why we can't replace them. So, so this is one characteristic of legacy software. And there is another uh, characteristic, that is poor quality and sometimes have inextensible designs. So with non-existent documentation, test cases, results were never achieved, poorly managed change history. The list can be quite long. So they are old softwares, but yet these systems support the core business functions and are indispensable to the business. So maybe sometimes you'll have to work on such software. Then let us come to the summary. Software is the key element in the evolution of computer-based systems and products, and one of the most important technologies on the world stage. Over the past 50 years, software has evolved from the specialized problem solving and information analysis tools to an industry in itself. Yet, we still have trouble developing high quality software on time and within the budget. So, these are the two factors, time and budget. So, we have to look for that. Then, software programs, data and descriptive information addresses a wide array of technology and application. And the legacy software continues to present special challenges to those who must. So this is what is the summary of the nature of. So with this, we come to the end of this video. If you have any questions, you contact me on Facebook, Twitter, Gmail, or Instagram. And if you like the video, press the like button. share with your friends, subscribe to our channel, Engineering and Technology Full. And don't forget to press the bell icon to get the notification. Thanks for watching. Have a nice day.